So we know how to find the missing side. We know how to find lengths if it's not something where we know two sides, but if it's special, 30, 60, 90, or 45, 45, 90, that kind of thing, we can do that. Now what if I have a right triangle? I know a side and an angle. It's not a special triangle, and I need to find another side. Or maybe I know two sides of a right triangle, but I need to find an angle. So this is where this comes in, trigonometry. This is one of my favorite videos. It's not quite CPC2C, but it actually teaches, of course, you have homework on everything. All right.
Well, it's like after the test.
What?
It's like after the test.
Well, even then sometimes, right? But sometimes. So tell me what this means, Nathan, trigonometry?
It's great for measuring a triangle.
Yeah, a trigon is a triangle. Metry, meter, is measuring. We're measuring triangles, and so the Greeks figured all this out for us. Based on ratios of sides in a right triangle and how these ratios relate to angle measurement. What? All right, here we go. We're going to learn what some of those things were in the Get Tricky with the video. You find these ratios relative to an angle. So you pick an angle in the triangle. You pick one of them. So here's triangle A, B, C, and then it's based on kind of what you know about the sides as well. Now, a naming convention. If this is angle A, the side opposite we call small a. If this is angle B, the side opposite we call small b. And if this is angle C, the side opposite is small c. So just a naming convention. So how many different side ratios can we make to angle A? So what do I mean by that? So if I've got angle A, one of the side ratios I can do is I can do this side to this side, right? I'm going to call that adjacent over opposite, right? Adjacent over opposite. So that would be C over A. What do I mean by C? This side C over that side A. What are some other ones that we've got? Do you see any other ratios we can make with just the side? Adjacent means next to. So if this is angle A, adjacent is like touching it, right next to it. The opposite is the side not touching it at all. So directly opposite. So the adjacent, you got two adjacent angles or sides here. This one and this one. And then that's the opposite. It works out, it works out. This is my right angle, so we don't usually take the ratios based on the right angle. We're usually doing the ratios based on one of these guys. So just looking at angle A. So I've got this side and this side. What other side combinations can I make? Yeah. Hypotenuse and opposite, right? So there's another ratio. So that would be B over A, right? Any other ones we can do? Yeah? Adjacent and hypotenuse. And so that would be C over B. Are there other ratios I can make? And it's kind of a little trick question, because can I turn these ratios upside down? Yes. So I'm just turning them upside down. Hypotenuse over adjacent. And these things here, these are the trig ratios. These are the trig ratios. But these are relative to angle A. Now if I was to look at angle C, like let's look at opposite over adjacent for A. Opposite over adjacent. It's A over C. But if you're looking at angle C, what's his opposite over adjacent? C over A. So it depends which angle that you're looking at. We'll continue. We'll talk about that a little bit more. So here we go. We are only looking at 3 of them in this class, but in reality, how many ratios are there? 1, 2, 3, 4, 5, 6. So we're looking at 3 unique ones. The other ones are just the opposites. We just kind of flip numerators and denominators, reciprocal relationships. So what are the ones we're looking at? So a sine, so let's say this is angle A. We call sine the ratio of the opposite over the hypotenuse. And we're going to abbreviate opposite with an O and abbreviate hypotenuse with an N. Sine is opposite over hypotenuse. I don't know where these names come from. That'll be interesting to figure out. Cosine is another trig ratio. It is the adjacent over the hypotenuse. So this angle It's this side over that side. And a tangent is the opposite over the adjacent side. Those are the ones that we know, or we're going to be learning about. But secretly, what other ones do I have? I have hypotenuse, not even so secretly, but hypotenuse over opposite. I have hypotenuse over adjacent, and I have adjacent over opposite. This one has a name. It's called cosecant. Minus cosecant. This one is secant. And this one is called cotangent. So when you take trig either next year or the year after, you'll learn a little bit more about cosecant, secant, and cotangent, but there's nothing to know. If you can do these, which we're learning this year, these are just opposite relationships, or inverse relationships. No, I don't want to use the word inverse. Reciprocal relationships. Okay, so we use this mnemonic, and they mentioned it in the video. So good, Toa, don't you know, right? So, it's to help us remember what the different ratios. Sine is opposite over hypotenuse. So here's the S, the O, and the H. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, toa. Let's say it. Ready? 1, 2, 3. So, toa. Because it's got to be in your brain here, because it is going to help you remember the different ratios and what they're called. Now, if you'll notice here, I've got this little strange-looking thing here. Anybody ever seen this thing before? Anybody speak Greek? Know the Greek alphabet? No? Look, we're learning some more. This is theta. So theta is very often we'll call this angle theta. So that's very often what we do. Other alpha, beta, we use a lot of the Greek letters to identify the angles, because the Greeks thought this up. Why not? What else? So here's our kind of summary. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent opposite over adjacent. So now let's look at this table here. What would be the ratios for angle C? So if I want the sine of C, because this is the sine of A, what's the sine of C? Sine is opposite over hypotenuse. So where's the opposite side to C? Here. Over, what's the side for hypotenuse? B. Yeah, this is in the middle of page 1 here, so we're hopefully following along. What's the cosine of C? Adjacent over hypotenuse. Adjacent over hypotenuse. The adjacent side is the one next to it that isn't the hypotenuse. So that would be this one right here, which is little a, over hypotenuse, which is lowercase b. Tangent of C. Opposite over adjacent. Remember, the adjacent one, there are two adjacent sides to C. The one that isn't the hypotenuse, so the adjacent leg, is going to be, what do we want here? So I've got C over A. Questions on what I'm doing, because sometimes it's like, what are you doing? Where are you getting this from? I'm just from here, opposite over adjacent. Opposite over hypotenuse, adjacent over hypotenuse. So they're different depending on where you're starting from. Okay, so this one I think did not print very well on your paper there. It got hidden a little bit. So on your paper where it's hidden, there should be an X up here and a 7, right, on your notes? We're making that correction. It got hidden by that graphic on top of it. So here's X. It's saying, what is the sign of X? It might help, especially at first, to label what you got. First of all, where's the hypotenuse? So let's call that one H. Relative to X. What is the opposite side? Yeah, 24. Relative to X, what is the adjacent side? Yeah. Well, it is an adjacent side, but I want the adjacent side, not the hypotenuse. So it's going to be the 7. So I guess I should say adjacent leg. That might be clearer. Then this is all just relative to X. So if I want the sine of X, and I'm going to put my little remembrance up here. So how do I find the sine of it? Opposite over hypotenuse. So what is the sine of X going to be? What's the opposite measure? 4, the opposite. And then what is the hypotenuse? So the sine of this angle, the ratio is 24 over 25. What is the cosine of X? Cosine of X. Cosine that is adjacent over hypotenuse? Yep. 7 over 25. I look for the adjacent leg, 7 over the hypotenuse. What about tangent? Tangent is opposite over adjacent. So what's the tangent of x? Yep. Well, yep. 24 over 7. Okay. Now let's do the same thing for this angle. Okay, we're not working so much with the 90 degree, but the other one that isn't 90. Now, I got to kind of redraw. Now, h is always h, right? Hypotenuse is always the side opposite the 90. But now, who is opposite angle y? Yeah, which one? The 7. And who is the adjacent leg to angle y? The 24. So what's the sine of y? Sine is opposite over hypotenuse. What's that going to be? Yeah? Good. Cosine of y, adjacent over hypotenuse. Yeah. Good. 24 over 25. How about the tangent of y? 7 over 24. Good. Please ask a question if you're like, where in the world are these numbers coming from? It's just, it's simple, but you gotta see it. Yeah. Yes, they are. Huh? Why is the 24 on top? Because relative to x, the opposite is the 24, and the adjacent is the 7. And relative to y, the opposite is 7, and the adjacent is the 24. So yeah, so it's really important to kind of know what angle am I at. And I would say at first, you may need to label these sides to see it. You don't have to do it forever, but at first. Because it can get confusing. Oh yeah. Now the 90-degree angles, they're a little bit special here. The sine of 90, I'm just going to tell you what it is. It's 1. The cosine of 90 is 0. And the tangent is sine. And this why it's a little hard to explain without kind of really getting a complete picture of where else these trigonometric things are coming from. A tangent is really a slope, and this is really a y value, and this is really an x value, and y over x can't divide by 0. Oh my gosh, it gets complicated. When you get into a proper trig class, which will be either next year or the year after, you learn something about something called a unit circle, and it helps you see why this is really a y value, and this is really an x value, and this is really y over x, which is slope. And you're going to get into this way, way more. So for now, we're just going to take it on faith. The sine of 90 is 1, cosine of 90 is 0, tangent of 90 is undefined. That one's harder to find with the triangle. All right, let's see what we got here. The calculator, thank heavens. Because, like, you know how I knew these on the top of my head? So do you have to memorize what all the values are of these? No, thank goodness. Back in the day, we had a big, in the back of every geometry textbook was a table of all the different sines and cosines and tangents. If your parents still have their old math books, you know, it's like an antique. Oh, look at all the sine tables, the trig tables. So we don't do that anymore because everybody has a calculator. So let's kind of work with the calculator a little bit. Here is the most important thing you need to know. You ready? See how I'm circling this word important? Important. Put it in degree mode. How do I do that? So turn on your calculator, and you're going to press the mode button. Mode is right next to the second Casey mode. Press it. See all this? Now, depending on what your what state it was in, I think the default is if you go down 1, 2, 3, see where it's radian and it's blinking? You want to move 1 to the right. So scroll to the right so that degree is blinking, and then you're going to press enter. Angles can be measured in degrees. We know that, right? Again, when you get into proper trig next year or the year after, you're going to learn about something called radians. And it's another way to measure the opening of an angle. And it's based on the arc length of the circle created when you open up an angle. So it's different from degrees. Degrees are kind of interesting. Do you ever wonder why there's 360 degrees in a circle? You ever wonder? Where'd that come from? 360? One degree, this was before that, the Babylonians, I think it was. They noticed, you know what they noticed? Which is kind of amazing when you think of these cultures. How long does it take the Earth to go around the sun? 365 days. So they were pretty close, weren't they? They figured a circle is 360. And so a lot of our numbers, we see a lot of 60 degrees and 30 degrees. They're all kind of variants on 360 because they were taking pieces of that 360 circle. So degrees are based on Babylonians. So the radiant is another way to look at it. It's less ancient. In some ways, I think it makes a little more sense, but that's not for this year. That's coming. That's why I think trig is really, really cool. So anyway, degree. This must be in degree mode or everything you do will be wrong. Okay, so on your paper it says, put it in degree mode, and I boldface that. You see it on the paper here, about 3/4 of the way down? Using the TIU 3+ calculator. Circle that, put stars around it, because you'll know when it's a test and you get them all wrong, like, I forgot to put it in degree mode. So always check that. Very, very, very important. All right, now how do you, yes. I would check it every time. Because I think the default, when somebody does a reset on memory, I think it goes to radians. Because really, once you get past learning about, once you learn radians, that's what you use, like all the time. So I think the default is radians. Check it every time because it will all be wrong otherwise. Now let's say I want to take a sine of some value. So where are those things? Pesky sine functions. Can we find it? Oh wait. First get out of here. So we click. See the click? Second, mode button gets you out. And then this is hard to see for me because I have terrible eyes. Okay, yeah, here it is. See where it says sine? Press it. Right? That's how you get the sine of an angle. And then we're going to pick an angle. I did sine of 30, which is a half. So if you put in a 30, you get a half. Sine of 30 is a half. So if you have a 30-degree angle, if you do an opposite over hypotenuse, it is always going to come out to a half. Now, let's just for fun, like let's say I forgot, because I want to show you what happens if you didn't change your mode, and then I try to take the sine of 30. That's not a half. So it is really, 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 really important. This degree mode. I can't stress it enough that you do that. Now there is a way to force degree mode. So if you're like, I'm not sure and I'm being extra careful, so I'm going to actually put it back in radian mode just to kind of prove all the points here. If I can do that quickly. So if I say sine of 30 and I want degrees, so let me see again. I can't read this little thing. I'm going to press the second button. And if you see where it says apps, if you look above it, it says angle. So second apps will give you an angle menu. That first choice is a little degree. If you press it, it's going to force it to be in degree mode, even though the calculator is in radian mode. So if you're really paranoid, and sometimes I am, if it was like, I don't know, an SAT or something, a big test, I might force it just to make sure I'm in the right place. I'm going to put my mode back. All right, so again, how did I get there? You see the apps key. Second, apps, it gives you a degree as your first choice. If you want to force it. And what is this? I think this just explains it. Press the degree mode, and there it is. Okay. So we're going to need to, so let's do a couple of examples here. Yeah? Well, I can't see what it says. Yeah, and you want the first thing, the degrees. Yeah, so if you put that after the number, that's what you get. All right, so we're going to find x and y here. So what do I have? I know one of the angles. I know one of the sides. So how do I do that? Well, I don't even need to do this, but I could. I am going to set up a trig ratio to find x. Now, relative to this angle, first of all, what is this? That's my hypotenuse. What's this thing? My opposite. So what trig ratio can I use if I have opposite and hypotenuse? Now we can write these down. You may want to have these handy at all times until it's in your memory. So I have an O and an H. So what should I use? So I'm sine. sine function. Sine, that's the abbreviation, S-I-N. The non-abbreviation is with an E on the end. Never use it. So it's going to be the sine of this angle, the sine of 32 degrees, is going to equal my opposite side, which is my I don't know, over my hypotenuse. Okay, so I'm just going to set up the ratio. Let's look for y now. Now, relative to 32, what is y? Yeah? It's the adjacent side. So to find y, what's my ratio? Yeah? What am I going to use that one? Cosine. I just set it up and then I'm going to stop right here to make sure we understand what we just did here. Questions, questions, questions. Where is this coming from, Natalie? Because to get to y, it's the adjacent over the hypotenuse, and that's cosine. Cosine is adjacent over hypotenuse for y, and opposite over hypotenuse is sine to find x. Well, before we solve it, I just want to make sure we see it, because this is key, this is critical. Did that help at all, Natalie? Because she's like, see what? No? A little. How do we solve it? Well, I want x by itself, right? How do you get x by itself? Multiply both things by 18. So x is going to be 18 times the sine of 32 degrees. Say, now what am I going to do with y? Also multiply that by 18. So y equals 18 times the cosine of 32. And now my calculator comes out. 18 times the sine of 32, depending on how paranoid do I put the degree in. Pretty sure I put it in degree mode. And I get some big long thing. And usually it'll tell you how to round. If it doesn't tell you how to round, the default is nearest 100. So 2 decimal places if it doesn't say. So what would I round this to? 9.54? Okay, and then this one is 18 times the cosine. 18 cosine of 32. To the nearest 100, 15.26? Is there a way to check that these are anything possibly close to reality? Because you know what if you were in radian mode? You didn't realize it? Is there a way to check this? Yeah.
So then X, did you do what you got?
Yeah, I could work backwards. But I'm thinking along the lines of, I have a right triangle. What do I know about the sides? Yeah? The Pythagorean theorem. So I'm going to take the square root of 15.26 squared. I'm just testing it, that I do it right. Plus 9.54 squared. This is the Pythagorean theorem. And I hope I get something close to 18, which I do. Why isn't it exactly 18 though? Why not, Rachel? Yeah, we did some rounding over here. So I don't expect to get exactly 18 if I had to do some rounding, but I'm pretty close. Phew. I was in the right mode. I wasn't in degree mode. I can actually check a little bit. So there's ways to kind of make sure, especially at first we're just getting used to this. All right, here's another example. Let's see what's going on here. I want to find x and y. And I have one angle that I know. So let's see. Relative to this, where's my hypotenuse? Well, that's always opposite the right angle. Which is the opposite side for 29 degrees? That's my opposite. And where's my adjacent? The y. So let's see. What should we find first? X is the hypotenuse, right? So let's see. What do I know? I have an opposite side, which I know, but I don't know this. So what's opposite and hypotenuse going to help you with? Again, put these to SOHCAHTOA up there just until it's in memory. So the sine of 29 is going to be the opposite side's value, which is 10 over the side I don't know. And then let's look at the setup for y. So y is an adjacent, and I have an opposite. Right? So you need a value. So I have an opposite, I don't know the adjacent. What should I use? Yeah? Tangent. So the tangent of 29 is going to be the opposite over the adjacent. So, is that getting slightly, maybe a tiny bit clearer going over some of this? Yes?
I have a question for that.
What would you do next?
From the graph,
Yeah.
we like it says if variables ambiguous, like maybe switch the sign.
From the video? Yeah, who's still paying attention? Because some people look at this and go, oh no, how do I solve that? And they're like, just swap them. How come I can swap them? How come I can? Yeah. Yeah, but why am I allowed to say flip these around? So that, huh? The video said so. Getting tricky with it. How come? Well, remember we worked with proportions? Aren't these cross products the same? You can swap these guys. Don't they have the same cross products? They're equivalent. You can also think about multiply both sides by x. What would I get? I would get x sine of 29 equals 10. Divide both sides by the sine of 29. And I'm back here again. So if it's in the denominator, you couldn't do a swapsies. So how do you find x is going to be 10 divided by the sine of 29? How am I going to find y? 10 over the tan of 29. So if they don't mind if I trust the calculator, 10 divided by the sine of 29 is about 20.63. And then this one is 10 divided by the tan of 29. That is 18.04. And again, if you want to check it, put this in your calculator, use the Pythagorean theorem, you should get approximately that 20.63 value when you square that. Oh my goodness, what do we think? Let's do the U tries. Yeah.
174.
What that? You got a different number than me? For which one?
When I did the calculation.
Let me check that in a second. Try some of these U tries here. Find those missing links and A, B, C, and D. And I'm going to give you the homework, but I'm going to shorten it a little bit. Yeah, just give me a second till I get the homework out. Okay, so work on these guys. I just want you to see the answer sheet behind. Right, I would like you to finish the U tries on your notes as well, in addition to side one of that worksheet. Everybody clear?